So to prove or disprove that a shape is a rhombus, if it is a rhombus, that means it's a parallelogram first and foremost, which we'll check. And then for a rhombus, it has to have either perpendicular diagonals, four congruent sides, or diagonals bisect or angle bisectors, but you can't really check angle measurements and coordinates. So you have to first make sure it's a parallelogram, which is pretty easy. Then you just check if either all four sides are congruent or if the diagonals are perpendicular. So you can take your pick of whichever of those two things you want to check to see if it is a rhombus after we know that it is a parallelogram. So if it's a parallelogram, that means that opposite sides are going to be parallel. Or we could also check to see if opposite sides were congruent. That would also mean it's a parallelogram. So we can also check to see if just one set of opposite sides is both parallel and congruent. So that would probably be the easiest to check because XY and WZ are parallel because they're both flat. They both have a slope of 0. So they are parallel. You can see that in a matter of half a second. Both have a slope of 0, so they are parallel. Do they have the same length? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. So X, Y, and WZ are parallel and congruent. Which means it's a parallelogram. That was in a parallelogram lesson, that's enough. If you have one set of sides that's both parallel and congruent, it's a parallelogram. Now we just said that these sides were each 5. If this shape, WXYZ, is a rhombus, then the other two sides also have to be 5. Or you could check to see if the diagonals are perpendicular. Either way will be fine. If you like distance formula, do distance formula. If you like slope formula, do slope formula. So if this is a rhombus, I think slope's going to be a little bit easier. If this is a rhombus, the diagonals are going to be perpendicular. They look pretty close, but to be sure, we got to check the slopes. So we need the slope of XZ. It goes down 1, 2, 3 over 1. Down 3 over 1. There's a slope. Then we check the slope of WY. It goes up 1, 2, 3 and over 9. Up 3 over 9. That reduces to 1/3. So then you compare those slopes. We have a negative and a positive. Opposites, good. 3 over 1, 1 over 3. Reciprocals, yes. So the diagonals are perpendicular. Which means it is a rhombus. So yes, this is true. If you did not, like I said before, if you did not want to do the slope, you could check the distance, which you can either do with Pythagorean theorem or distance formula, doesn't matter. This side's 3, this side's 4, so 3 squared plus 4 squared. That's 9 plus 16 is 25, so that means that this side is 5. Going through Pythagorean theorem, you do get 5 here. Same thing here, you get 4 and 3. 3 squared plus 4 squared still equals 5 squared. So all the sides are 5. That would have worked to show that's a rhombus also. So to determine what type of parallelogram this is, if it's a rectangle, a rhombus, or a square, first it needs to be a parallelogram, which, just like in the last example, it's got a length of 5. This one has a length of 5. They both have a slope of 0, so yeah, it's a parallelogram. Opposite sides are congruent and parallel. It looks like it might be a rhombus. A quick way to check would be to check to see whether or not the diagonals are perpendicular. So the slope of BD. Down 4 over 2. And the slope of AC. Up 4 over 8. So that reduces to negative 2 over 1. This reduces to positive 1 over 2. We have a positive and a negative, and they are reciprocals, so they are perpendicular. So the diagonals are perpendicular, so it's a rhombus for sure. We could then check to see if it's a square, because a rhombus with right angles would be a square. Clearly, this does not have right angles. BC and AB are not perpendicular, so it does not have a right angle, so it's not a rectangle, which means it's not a square. So the best name for it is just rhombus. Again, for this shape, you want to know whether it's a rectangle, rhombus, or square. It doesn't look like a rhombus, so we can rule that out pretty quick with just checking either the lengths of the sides or the diagonals. If you wanted to check explicitly to show that it's not a rhombus, you would check the slope of the diagonals, FH. That goes down 1, 2, 3, 4, 5, and over 5. Down 5 over 5. And the slope of EG up 1 over 7. So that's negative 1 over 1 and positive 1 over 7. Those are not reciprocal, so they are not perpendicular. It's not perpendicular, so it's not a rhombus. Since a square has to be a rhombus and a rectangle combined, it's also not a square. It looks like it very likely is a rectangle, so we just have to check if it has a right angle. So to check to see if this angle is a right angle, we just have to see if those two lines are perpendicular, those two sides. So now we'll check FE, slope of FE. Goes up 3 over 1. And the slope of FX goes down 2 over 6, which reduces to negative 1 over 3. So we have a positive and a negative. 3 over 1, 1 over 3, they are reciprocals. that means that that angle is a right angle. So if it has a right angle and it's a parallelogram, I guess we didn't check that right off the bat. We just found the slopes of those two. So if we found the slope of this one, which is down 2 over 1, 2, 3, 4, 5, 6. That one's also down 2 over 6. So those are parallel. So we're halfway to a parallelogram. This side is up 3 over 1. So those two sides are parallel. So opposite sides are parallel, and the sides that are next to each other are perpendicular. Parallelogram with a right angle is